Hi guys, welcome back to the last segment of the show. So right now we're going to be looking at some questions that bring together all of what we have actually spoken about so far, right? Remember, we looked at the first theorem, which we said was when a tangent is perpendicular to the radius or the radius is perpendicular to the tangent. Let me say it properly. We start with the radius and then go to the tangent. So a radius is perpendicular to the tangent and not the other way around, because it's the radius that's perpendicular to it, not the tangent being perpendicular to it. Number two, we looked at the concept of me having two tangents from the same external point to one circle and they're equal to each other. The last theorem that we looked at that has to do with tangents was when we have what you call a tangent chord theorem, right? With the tangent chord theorem, we are talking about an angle between the tangent and the chord, which I will normally show you like this, will be equal to the angle in the alternate segment. Alternate segment will be the angle that is subtended by the same chord that forms an angle with this particular tangent. So please do look at that and think about that. But for now, let's just jump right into these questions that I know that you're going to enjoy, and you're going to take some time to try and investigate them further so you can understand clearly what is happening here. But let's look at them together. So, in the following sketch, or rather in the sketch alongside, I just don't have enough space for me to bring everything down here. So I put it on the side so you can see clearly what's happening. O is the center of the circle. Please remember, I said I will not say anything that is not important on the statement. So for you to know that O is the center of the circle, it makes it important, because then if I do tell you that AB is the tangent, then this will be a perpendicular relationship. Only if I told you that O is the center. But if I did not say that, you do not even think about a perpendicular relationship between the two. But for now, I did tell you. So this is important. I also tell you that AB is a tangent. Automatically, you can see my 90 degrees as I've shown you there. What I also know is that OA is parallel to BC. So my OA is parallel to BC, making the angle O1 to be also 55 degrees, right? And my reason will be alternate angles. And that's because we were told that B2 is 55, right? So we need to determine with reasons. Now, I know that our reasons, we normally think that our reasons is just to say, okay, because that's a line, because that's not the case. There are acceptable Euclidean geometry reasons that you need to use. With every theorem that we've done thus far, I've always given you a reason at the end for you to actually know what is the reason that we will use when you try and talk about that particular theorem. So please go back to the other lessons. I hope you wrote down those reasons so that you know exactly what are the types of reasons that you're going to use when you're trying to prove certain things or solve certain things. But those are the acceptable reasons. And you can always find it as well in the DBE page. Whenever you then trying to study, you can always go to our Gauteng Department of Education page, and you can find the acceptable reasons for Euclidean geometry that they've put forward for you to be able to know them. So please make sure that you do adhere to those reasons, because I promise you, we're going to penalize you if you don't use the proper reasons. But for now, let's just try and solve these ones. So they want us to find the size of A, right? So I go where I have enough space. Remember, I did say that this is 55 degrees. Since that is 55 degrees and this is 90 degrees, I need to first say, how did those two angles that I've included on my diagram come about? And then I can solve for A. So firstly, I will then say that B 1 is equals to 90 degrees. And my reason for this will be radius perpendicular to tangent. Remember that. And then also, I also wrote that my O1 was equals to 55 degrees, right? And the reason for this will be alternate angles. And why is it alternate angles? Because AO is parallel to BC. You do need to state that. Then from there, I can then talk about in triangle ABO, I can then use the theorem of Pythagoras, right? Not the theorem of Pythagoras, because it's 90 degrees. I'm confusing it now. I was thinking we are trying to find OA. We are trying to find angle A. So to find angle A, I will then use sum of angles in a triangle. So I will then say that A is equals to 180 degrees minus 90 degrees minus 55 degrees. And my reason for this will be sum of angles in a triangle. You know they are supplementary to each other. Therefore, angle A will be equals to 180 minus 90 is 90. 90 minus 55 will then be 35 degrees. And that will be the value there. So make sure. And you can see every statement that I've actually claimed here, because of something that I am thinking about, I did give a reason why that is the case. So to mark this, maybe if we were to mark it, I can mark that and its reason, this and its reason, and this statement and its reason and the answer. So I can roughly give you something like 7 marks, hypothetically speaking, really, if I was to mark this for you. So you always need to please include your reasons there. Now, PA and PB are tangents to the circle at A and B respectively, right? Since that they are tangents, I know that I will immediately claim that those two are equal to each other. What do I know? APB is equal to 36 degrees. Let's see what do they want us to do here. In the following sketch, I did say those are tangents. I want you to find the size of A2, right? So firstly, I will then first claim that AP is equals to PB, right? And the reason will be tangents from same point, right? Remember that. And then because of that, I will then say that angle A1 is equals to B. Angle A1 is equals to B. And my reason for this will be angles opposite equal sides, right? Angles opposite equal sides. Therefore, my angle A1, because that's what will help me to link it to A2, is equals to 180 degrees minus 36 degrees divided by 2, right? And this will be sum of angles in a triangle. And then you can then find what that angle is. So 180 minus 36 will be 144. 144 divided by 2 will then be 72 degrees, right? Since it's 72 degrees, I will then say, therefore, A2 is equals to A1, which is equals to 72 degrees, and this will be vertically opposite angles. I know that this is one reason that you know about. Therefore, that will be vertically opposite angles, because they wanted us to actually find that angle there at the top. AB and CD are tangents also to the circle at B and C respectively. C1 is 30 and D is 44 degrees. So what do I know here? I have two tangents, but now look at these two tangents of mine. They are not from the same point, right? This is one tangent and that's one tangent. They are not from the same point, but they are tangents to the circle. So you need to please note that. And they want me to find the size of B1 and the size of B2 there. So to find the size of B1, firstly, what do I know? I will try and analyze this first. So I know that this is a chord, that is a tangent, and in the alternate segment, that will be the angle there. So this angle and that angle will be equal to each other. So remember, guys, chord, tangent, the angle in between here will be the angle opposite the same chord. I repeat, chord, tangent, the angle here will be equal to the angle opposite this chord. So please note that, right? So what am I saying? Chord, tangent, the angle in between there, which is this 30, will be equals to the angle opposite that chord there. So I will simply just say my B1 is equals to C1, which is equals to 30 degrees. My reason is, remember I said this is just 10 chord theorem. You don't even need to say 10 the theorem at the end. You can just say 10 chord. That's the main idea there. Also to find B2, so already I know that this is 30 degrees. I know that. Now what else do I know? I also know that this angle here is actually going to be 180 minus 30 minus 44. So firstly, I will say that E1 is equals to 180 degrees minus 44 degrees minus 30 degrees. And what is the reason for this? Will be sum of angles in a triangle. And this will therefore be equals to 180 minus 44 is 136. 136 minus 30 will be 106 degrees, right? And then from there I can claim that E2 is equals to 180 degrees minus 106 degrees, and this will be adjacent angles on a straight line, right? On straight line. You know they add up to 180 degrees, so this will therefore be equals to 74 degrees. Therefore, my conclusion, which is what I wanted to find, my B2 is equals to E2, which is equals to 74 degrees, and my reason will therefore be 10 chord theorem. Right? So I know that with most of these questions that we've done thus far, we've looked at questions where it's straightforward. You can already see that if I link these two, this is what I will get. But here, you first need to find something. Already you can see from my diagram that B2 links to E2 properly, right? Because that's the tangent chord theorem. But I also don't know what E2 is. So what is my goal? First find E2. If I know what E2 is, then consequently I know what B2 is. But let me show you the 10 chord in this diagram, right? Remember I said chord tangent equals to the angle opposite the chord. Please remember that at all times. Right, so this angle here must be equal to that angle there because of the 10 chord theorem. Always remember that. Now our summary is we've looked at the radius is perpendicular to a tangent. That's one of the theorems that we know. We've also looked at tangents from the same external point. Then lastly, we looked at the concept of 10 chord theorem, which you saw I just applied now. So far with my concept map, guys, the big idea that we tried to look at was the concept of circle geometry. We started looking at the concept of lines, right? With lines, the only line we didn't do was the tangent and the cyclic quad, but everything else we looked at. And then we went on to look at angles, and with angles we looked at same segment and angle at the center and right angle, which you know is always there in geometry. And then with the cyclic quad, an exterior angle is equals to interior opposite, and then the opposite angles are normally supplementary to each other. And then lastly, tangent talks to the alternate segment. Remember, segment or alternate segment has to do with a chord that divides those that particular circle into two segments, minor and major segment. Guys, I hope you've enjoyed Euclidean geometry. I really have enjoyed actually looking at it with you, and I hope you also learned a lot from this. But from me to you, remember, mathematics is food for the soul. Until next time, I will see you guys.